Okay, so here we're kind of reaching a pinnacle point. So we have some proofs that had you build an equation. We have some proofs that manipulated the side lengths to prove side lengths. This is going to be a proof that actually does, excuse me, it does both. It's not going to be as weird as long as the diagram implies. These next two are actually going to be much, much longer, much weirder, especially this one. This proof at the very end is like, if you can do this, you are doing above level work. Like you're doing like honors level or higher work right now. But like right here, this is kind of like the last step on that train before we jump on to the really, really tough stuff. And so we're back to proving triangles are congruent. ABF and EDG. To be really clear on where these are, let me choose a different color here, maybe pink. Okay. To be super clear on where these are, I'm going to go ahead and like highlight them. So ABF is just it's this triangle here, and it overlaps the other one. So they're kind of pushed together, smushed together. And so EDG is this guy right here. All right, so EDG, right? And so we have to prove these triangles are congruent. Now, what that means is we're still looking for shortcuts, and we're still going to use the given information to help us do it. But since they're overlapping, that's going to create an opportunity for some weird angles and some weird side lengths to be congruent. But let's go ahead and start the analysis. So we have AB and ED are congruent. AB is a side. I'm going to go to mark it. I'll double her up right now, and then ED is over here. So we do have a side length that's going to be congruent to a side length. AGC, let's be really careful. AGC is actually this angle right here. I'm going to double angle it. Okay, I'm going to call it angle 1. That's going to be congruent, so that's angle 1, to which I'm going to call angle 2, which is EFC, which is right here. What's weird about this is that those aren't actually parts of our triangle. And if you notice, they're kind of in between one of the sides. And so we can't quite use that information directly. But if we zoom in here, if we look at angle 1 and we look at angle 2, they actually do something very important, which is that they form a line with this angle. Okay? So if I look at angle 1, I'm going to call this angle 3. If I look at angle 1 and angle 3, they do form a line together, which means they have a very particular relationship. We've seen this actually before. We know that angle 1 and angle 3 are now linear pairs. Which means that the measure of angle 1 plus the measure of angle 3 has to be 180 degrees because they're supplementary. I'm just going to abbreviate that right there. If we slide over to this one, we're going to see a similar relationship. Let's call that 4. So it's almost identical. They're going to form a line together. And so angle 2, angle 4 are linear pairs. I'm going to say LP, which means that the measure of angle 2, measure of angle 2 plus the measure of angle 4 has to be 180 degrees. Okay. This is good news because if we look at these two equations side by side, we're told angle 1 and 2 are congruent. Angle 1 is congruent to angle 2, and so that means that the measure of angle 1 is got to be the same as the measure of angle 2. And so if I start bringing this information together, like if I combine these two pieces, what that means, because ultimately we want to get 3 and 4 being the same, right? We really want to show 3 and 4 are the same thing. If I bring these two together, I can actually exchange 1 for 2. And so like the rewritten equation here says the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Okay, and this already says that. I mean, that says the measure of angle 2 plus the measure of angle 4 is equal to 180 degrees. Okay, and so examine this because it's subtle, but there's something really important going on here. Angle 2 is the same in both equations. 180 is the same in both equations. And so if everything around them is the same, you have to ask yourself, what does that mean for angle 3 and angle 4? Like if we combine these two equations together now, the only conclusion that we can reach is that angle 3 has to be congruent to angle 4. It has to, because everything else around them is also congruent. And so those pieces have to be congruent too. This is like the rule of congruent parts. If everything around them is the same, then those have to be the same too. And so what that really means is that we have another set of angles. Like we have angle 1 congruent to angle 1 here. We have this angle here that was given. Like it doesn't actually say that. Oh, does it say that? No, it does not. So in their givens, it was not said it was congruent, but they gave it to us. And so this is another angle. So this is angle 2, and this is angle 2. And so if you follow the triangle, we have a side that runs into an angle, and this one has to run actually all the way over here to the blue one. We have an angle as well. And so we're going to use angle, side to prove this. And I bet if we look at a statement of intent, that's exactly what's going on. To prove the triangles are congruent, I will use AAS. To meet the shortcut, I'll use the given information, and that's a lot of givens. Like we had givens here, 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 and here. Along with linear pairs, which is what we started with, definition supplementary, and a little bit transit property. And I think the transit property is really coming into play right here in this step. Okay? So we had to do a little algebra manipulation too, but I mean, that's just the way it is. And so I think I'm gonna write this as a flow proof. So let's get into that. So we have angle, which is very uninteresting. We have this other angle, which is I think going to be terribly complicated. And then we have the side length, which again is very uninteresting. In fact, let's write the angles right really quickly. So I have the angle at A is congruent to the angle at E. And that's because it was given. It was given the diagram instead of as a statement, but it still counts as it being given. We have the side length. I'll go ahead and get that out of the way as well. AB is congruent to ED. And that was given. Man, that's terrible. Let's try it one more time. I can really that a perfectionist, but like that even bothered me. And that's because it was given as well. Okay, and so we have to deal with this kind of middle mess of an angle that we have created for ourselves. So I'm going to give myself a little more room here. Right? And so we have to establish some things kind of right off the bat. So we know that angle 1 is congruent to angle 2 because it was given to us. But we also know that angle 1, angle 3 are linear pairs. Okay, we also know that angle 4 and angle 3 are linear pairs. Which means immediately that the measure of angle 1 plus the measure of angle 3 equals 180. It also means the measure of angle 4 plus the measure of angle 3 equals 180. Okay, and this is because of the definition of supplementary. Okay, this is also the definition of supplementary. Okay, and so let's kind of box these up. Okay, and so if I take this equation and I take this information, because in the end, I know that if 1 and 2 are congruent, I know measure of angle 1 is equal to the measure of angle 2. Okay. So if I combine this information and this information, what I have is a measure of angle 2 plus the measure of angle 3 equals 180 degrees, and that's because of substitution. Okay, and if I just kind of swing this one down, measure of angle 4 plus the measure of angle 3 equals 180 degrees. Okay, no justification needed because I'm just swinging it down. This is that congruent parts thing, right? So, 1, 2, yeah. So I want to show 3 and 4, yeah. No. Oh, I messed up here. Let's go back. I found a mistake. That should be angle 2. 2 and 4. 2 and 4, yeah. So that's going to be 2 and 4 here. Because it should be 2 and 4 right here, guys. Sorry about that. I kind of caught a mistake there. It's getting late. Sorry about that. So it'd be 2 and 4 right here. Okay, there we go. And so remember, our goal is to show that 3 and 4 are congruent. Okay, and so we have angle 3 and 4 right here. And then the thing we have to notice is that all the pieces around them, 2 and 2 are the same, and 180 and 180 are the same. And so this is a form of the transit property. So we can say angle 3 is congruent to angle 4 because of transit property. Okay. So we're gonna box that one up too. Okay, and so that one's much more of a beast than the other ones. But in the end, we do have one angle here, one angle here, and then one angle here. And we can now combine these. And so if I bring these all together, and I'll kind of bring over to the side here. So if I can bring all these three together, I have met angle, angle, side. And so I'm now prepared to make a statement about ABF and EDG. So triangle ABF is congruent to triangle EDG by the angle, angle, side triangle congruency theorem. Okay. And that's going to be our final statement. And so like the middle step, and this is maybe why flow proofs sometimes work better, it's because you're just bringing together a whole bunch of statements. Like you're making observations about different equations. We're doing a lot of algebra to kind of bring those things together. But in the end, we're just proving side lengths. So, or in this case, angles, excuse me. So I do have two angles in the side that proves triangles are congruent, right? So that one's definitely tougher. You're gonna have to take more than one pass at that, I think. I mean, I know I did. Like you saw me even mess up. Like I wrote the proof myself, and I still kind of messed up there. So definitely take this as an opportunity for practice. The next two are going to be substantially more difficult, but they're on the same, the same kind of tilt as the rest. We're going to have to think really hard about how to manipulate the algebra, in addition just to geometry. All right. So thank you guys. I'll see you guys in the next one.